Solving addition and subtraction equations. The target for this lesson is, I can solve equations involving addition and subtraction. Example 1. We'll do this problem together. Solve each equation using a number line. Check your solution. Problem A. X plus 9 equals 14. When using a number line for addition or subtraction problems, you should start with the value that the equation equals, and then determine which direction to move to find the missing value. The equation is set equal to 14, so we will start at that value on the number line. I notice that some number, x, plus 9 equals 14. This means that the missing value is smaller than 14 by 9 units. So we need to move 9 units left on the number line to find x. 9 units left of 14 is 5, so x equals 5. Let's check our solution by substituting 5 for x in the original equation. Does 5 plus 9 equal 14? Yes, 5 plus 9 equals 14, so x equals 5. Problem B. We'll do this problem together. X minus 5 equals 7. Again, start with the value that the equation equals, and then determine which direction to move to find the missing value. The equation is set equal to 7, so we will start at that value on the number line. I notice that some number, x minus 5, equals 7. This means that the missing value is larger than 7 by 5 units, so we need to move 5 units right on the number line to find x. 5 units right of 7 is 12, so x equals 12. Let's check our solution by substituting 12 for x in the original equation. Does 12 minus 5 equal 7? Yes, 12 minus 5 equals 7, so x equals 12. Extra example 1. You'll try this problem by yourself. Solve the equation 3 plus x equals negative 5 using a number line. Check your solution. Pause the video and try this problem on your own. When finished, unpause the video to see if you were able to successfully solve the problem. The answer to this problem is a number line moving 3 units to the left from negative 5, landing at negative 8. X equals negative 8. Here are some key ideas that are good to know. An equation is like a balance. The expressions on each side of the equal sign must have the same value. When solving an equation, the scale must stay balanced. Whatever operation is performed on one side of the equal sign must be performed on the other side of the equal sign to keep both sides equal. For example, to determine the value of x in the scale pictured here, 4 blue circles would need to be removed from each side of the scale to keep both sides equal. The value of x in the model is 7, because 7 plus 4 equals 11. The process of solving addition and subtraction equations uses the addition and subtraction properties of equality. For any numbers a, b, and c, if a equals b, then a plus c equals b plus c, and a minus c equals b minus c. Inverse operations are used to solve equations. Addition and subtraction are inverse operations. You may have noticed that inverse operations were used to move along the number line or to balance the scale. Example 2. We'll do this problem together. Solve each equation. Show your work and check your solution. Problem A. X plus 4 equals 11. Copy the equation x plus 4 equals 11 and draw a vertical line through the equal sign to help you stay organized. We will use inverse operations in order to isolate the variable, or get the variable by itself. In this case, we need to get x by itself by removing the plus 4. The inverse of addition is subtraction, so we will subtract 4 to get x by itself. Any operation done on one side of the line to cancel out a value must be done on the other side as well, so we will subtract 4 on the right side of the equation. Positive 4 minus 4 is 0, so all that's left on the left side is x. 11 minus 4 is 7. Our equation now reads x equals 7. To make sure that 7 is the solution to this equation, we will substitute 7 into the original equation. Does 7 plus 4 equal 11? 7 plus 4 is 11, and 11 equals 11. Yes, 7 is the solution to the equation. 39 plus m equals 23. Copy the equation 39 plus m equals 23 and draw a vertical line through the equal sign to help stay organized. To get m by itself, we need to get rid of the positive 39. The inverse of positive 39 is negative 39, so we will subtract 39 from both sides of the equation. 39 minus 39 is 0, so m is the only term that remains on the left. 23 minus 39 is negative 16. The equation now states that m equals negative 16. To check that negative 16 is the correct solution, let's plug negative 16 back in for m in the original equation. Does 39 plus negative 16 equal 23? 39 plus negative 16 is 23, and 23 equals 23. So yes, the solution is m equals negative 16. Extra example 2. You'll try this problem by yourself. Solve each equation. A. Y plus 7 equals 15. B. 5 equals P plus 26. Pause the video and try these problems on your own. When finished, unpause the video to see if you were able to successfully solve the problems. The answer to problem A is y equals 8. The answer to problem B is P equals negative 21. Example 3. We'll do this problem together. Solve each equation. Check your solution. Problem A. Y minus 3 equals 14. Copy the equation y minus 3 equals 14 and draw a vertical line through the equal sign to help you stay organized. We will use inverse operations in order to isolate the variable. In this case, we need to get y by itself by removing the minus 3. The inverse of subtraction is addition, so we will add 3 to get x by itself. Any operation done on one side of the line to cancel out a value must be done on the other side as well, so we will add 3 on the right. Negative 3 plus 3 is 0, so all that's left on the left side is y. 14 plus 3 is 17. Our equation now reads y equals 17. To make sure that 17 is the solution to the equation, we will substitute 17 into the original equation. Does 17 minus 3 equal 14? 17 minus 3 is 14, and 14 equals 14. So yes, 17 is the solution of the equation. Problem B. We'll do this problem together. Negative 6 equals m minus 2. Copy the equation negative 6 equals m minus 2 and draw a vertical line through the equal sign to help stay organized. We need to get m by itself by removing the minus 2. The inverse of subtraction is addition, so we will add 2 to get m by itself. Any operation done on one side of the line to cancel out a value must be done on the other side of the line, so we will add 2 on the left side as well. Negative 6 plus 2 is negative 4, and negative 2 plus 2 is 0, so all that's left on the right side is m. Our equation now reads negative 4 equals m. To make sure that negative 4 is the solution to this equation, We will substitute negative 4 into the original equation. Does negative 6 equal negative 4 minus 2? Negative 4 minus 2 is negative 6, and negative 6 equals negative 6. So yes, negative 4 is the solution to this equation. Extra example 3. You'll try this problem by yourself. Solve each equation. A. N minus 8 equals 21. B. Negative 143 equals x minus 71. Hit pause and attempt these examples. Check your answers by resuming the video to see if you got the correct answers. The answer to problem A is n equals 29. The answer to problem B is x equals negative 72. Consider this. What are inverse operations? How is an inverse operation used to solve an addition or